Hello, my name is Prasanna Naidu, and my research topic is a robust defense mechanism for denial of firewalling using game theory. In this paper, we mainly focus on finding a distinct approach in order to mitigate or minimize the effects of denial of service attacks on firewall. A novel approach is being brought into picture to counter these attacks using game theory. There are two key elements in this research. One is the firewall, another is the game theory. The denial of service attacks on firewall, also called as denial of firewalling, which is basically the firewall being overloaded by specially crafted ICMP packets. Game theory is a set of analytical tools used to model and understand the strategic interaction between decision makers under certain assumptions. Firewall, as we know, is the first line of defense when it comes to network security. Firewall attacks takes place considering two key elements. One is the firewall policy, another is the firewall fingerprinting. Firewall consists of certain policies and rules under which it decides the packet filtering methods. The policy decides the incoming packets, acceptance and rejection rules. The firewall policy consists of sequence of rules where each of the rule identifies a predicate over five various fields, which are source ports, destination ports, IP protocol, source IP address and destination IP address. Firewall fingerprinting is basically identifying the implementation of the firewall. This is also the initial stage which is undertaken by the attacker to execute DOS or DDoS attack on a firewall. Firewall basically are closed source and it is comparatively difficult to gather any information regarding them. Numerous tools like Nmap, Zenmap or other packet sniffing tools are being used to scan the host operating system in order to identify the firewall being used. Now we come to the mitigation approach, which is the game theory. Game theory is one of the commonly used approach to describe the interaction between two entities whose decisions affect one another's gain. In this paper, we have presented a holistic approach in order to show the interaction between attacker and defender as a game, where every move of an attacker does represents number nodes used and its transmitting rate, whilst the defender action includes controlling the flow rate threshold of incoming packets in the firewall, which allows the firewall to stop the traffic from the nodes where the rate of transmission is larger than that of the threshold. This is achieved by Nash equilibrium. Nash equilibrium basically states that the action chosen by the attacker or defender is best given the choice of the other player. So as you can see that we have proposed a three-layered game theoretical framework where each layer are interconnected to each other. The top layer consists of grid of game sensors that gathers all information from our system. They are under continuous monitoring activity and the entire knowledge collected is shared among all the sensors and utilized by the top layer. The second layer consists of a central management unit whose main purpose is to aggregate gathered data in a global form, also helping in detecting attacks such as denial of service attack, which will be a key point of focus in this research. The third layer represents the central element, the training model. It is an optimal forensic capability in the sense that this is efficient in handling all the incoming network traffic and storing data and logs safely. So in this you can see that we have proposed a network environment where the incoming packets are classified as rogue packets and legitimate packets. A firewall is considered where our game decision agent stands, which is responsible for filtering packets. All the rogue packets are either discarded or redirected to a honeypot, whereas the legitimate packets are being forwarded to the system. As our research is focused on the defense mechanism, we would be considering actions from a defender's point of view. The action consists of either redirecting or discarding the traffic. Two thresholds, E1 and E2, have been chosen by the defender to decide his actions on incoming traffic by computing the total flow rate R into U for a source code where U is the number of flows for the node, and R is the bitrate flow. From a particular source node K, the defender observes that the flow rate R into U is less than E2. Then the firewall permits these flows to reach the target system. On the other hand, all the lows from the source node K are being redirected to the honeypot. If R into U is greater than E2 or R into U is less than E1, finally, if R into U is greater than E1, all the incoming traffic is being dropped by the firewall. These two thresholds creating two optimal filters, F1 and F2, which categorizes the permission dropping and redirection of the packets. The filter design can be found in these two equations. Thank you.